There are many elements in nature, and in order to better understand their properties, we have to classify them. And throughout the history, scientists made many attempts to classify the element, and we're going to study some of them. So, why scientists made many attempts for the classification of element? First is to facilitate their study, to make their study more easier, then to find the relation between element and their chemical and physical properties. And through the lesson, we will study the Mendeleev periodic table, Moseley's periodic table, and the modern periodic table. First, Mendeleev. The Mendeleev table considered the first real periodic table for classifying the element, and by the time of Mendeleev there were only 76 elements known to science. So how Mendeleev made his table? So he prepared a 76 card, and on each card he wrote the symbol of the element, the atomic weight, the melting point and boiling point, and some other characteristics. Then he arranged elements of similar properties in vertical columns, we call them groups, and he classified the element of each main group into two subgroups, group A and group B, and that's due to the difference between their properties. So Mendeleev, this is the periodic table of Mendeleev. The groups and each group A and B subgroup. So what Mendeleev discovered? He discovered that the atomic weight of elements increase in an ascending order on moving from the left side to the right side of the table in an horizontal rows, we call them periods. So as we go from right to left, the atomic weight of the element increase in an ascending order. And that the properties of element were repeated periodically by beginning of each period. So what are the advantage and disadvantage of Mendeleev tables? The advantage that he predicted of a discovery of a new element. So he predicted that we will discover new element. So he left gaps, empty cells in his table for those elements, and he corrected the atomic weights of some element which were estimated wrongly. And the disadvantage of Mendeleev tables, that he had to make a disturbance in the ascending order of the atomic weights of some element to put them in groups that suit their property. So in order to put the element in their proper position in the periodic table, he had to disturb the ascending order of the atomic weight. And he had to deal with the isotopes of one element as different elements due to the difference in their atomic weights. Then, in 1913, the New Zealand scientist Rutherford discovered that the nucleus of atom contains a positively charged particles called protons, and in the same year, the English scientist Moseley discovered, after studying the X-ray properties, that the element properties relate to their atomic number, not to their atomic weights. And based on that, he made his modification on the periodic table, where he arranged elements in an ascending order according to their atomic number, where the atomic number of each element increased by 1 from the preceding element in the periodic table. So as we go from left to right, each element increases by 1. Then he added the zero group, which include the inert or noble gas, and he added 2 groups below the table for the group called lanthanides and actinides. Then came the Danish scientist Bohr with the discovery of the main energy levels, and the scientist discovered that each main level contains a definite number of levels known as sub-energy level, which are S, B, D, F. This discovery led to the identification of the accurate composition of the atom, where the element classified in the modern periodic table in an ascending order according to their atomic number and the way of filling the energy level with electrons. So the number of known elements in the modern periodic table is 118 elements. 92 of them are abundant in Earth crust, while the rest are prepared artificially. And the modern periodic table consists of 18 vertical groups. Each group has a modern number and traditional number. 7 horizontal periods, where each period starts by a filling of a new energy level. And the elements of modern periodic table are classified into 4 blocks: block S, B, D, and F. So that is the modern periodic table with the 4 blocks: block S, D, B, and F. So block S, they are located on the left side of the periodic table. All group of block S take the letter A, so we call this 1A, 2A, and they are arranged into groups. Block B, they are all located in the right side of the periodic table. All group of block B take the letter A except the zero group, 18, which is the noble gas. So all those A, so this called zero group, and they are arranged in 6 groups starting from 3A. So 3A, 4A, 5A, 6A, and 7A. The group D, they are located in the middle of the periodic table. All group in D block take the letter P except the group number 8. They are known as the transitional element. They start to appear from period number 4. They are separated between the S block and the P block, and they are arranged in 10 groups starting from 3B, 4B, 5B, 6B, 7B. The group 8, they are 3 vertical columns, then 1B, 2B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. Finally, the F block, they are below the periodic table. They include the lanthanides and the actinides. And we can determine the position of element of groups A by knowing their atomic number. So first we write the electronic configuration of the atom, then the number of energy level indicates the period of the element. The number of electrons in the outermost energy level indicate the number of group. So the number of energy level tell us which period. The number of electrons in the outermost energy level tell us the number of group. So we have here carbon 6, so carbon with 6 electrons, write the configuration, 2, 4, so we have 2 energy level, so period, 2 group 4A. The potassium 19, write the configuration, 2, 8, 2, 8, 8, 1, so 4 energy level, so period, 4 group 1A. So from all that we conclude that the element of the same period, they are similar in number of energy level. So all period have the same number of energy level occupied by electrons, but they different in their chemical properties because they are different in the number of electrons. in the outermost energy level. But the element of the same group, they are different in the number of energy level because each element exceed from the previous one by a complete shell 8 electrons. But they are similar in their chemical property because they have the same number of electrons in the outermost energy level. So through the lesson, we use terms like isotopes and atomic weight. So this part is for your understanding. You don't have to memorize any of this, just to understand. So the isotope is a form of chemical element which the atom has the same number of protons but different number of neutrons. So, for example, we all know that this is carbon, and the carbon have mass number of 12 and the atomic number of 8. So it has 6 protons and 6 neutrons. So we also have carbon 13. They have the same atomic number, 6 protons, but they have 7 neutrons. And we also have carbon 14. Also have the same number of protons, 6 protons, but different number of neutrons. And the atomic weight, we all have, know this is boron 5. We have 2 isotopes of boron. We have boron 10, which is the atomic number 5 and the mass number is 10. So this is boron 10. Okay? So its weight is 10 atomic mass unit. And we have the boron 11. So it has atomic number 5 and mass number of 11. So imagine we want to know if we blindly take a boron atom, what will be the mass of this atom. So simply you can take the average of both, but this would be wrong because in doing this we assuming that both boron 9 and boron 11 have the same abundance in Earth, but this is wrong. The boron 5 only exists by 20%, and the boron 11 exists by 80%. So we include those in our calculations. Will be 10.8 atomic mass unit. So the atomic weight is the average mass of all naturally occurring isotope based on their abundance. So the atomic weight is the average mass of all isotopes of the element. Thank you.